On the job site, you've always got to be in control. Maintaining control allows you to keep things safe, productive, and efficient. With potential energy-related hazards like extreme heat, high pressure, electrical current, and even gravity, it's especially important to be in control of the tools and equipment you use. Some tools and equipment can be hazardous even when they're turned off. If you're performing service, doing maintenance, or just changing an attachment on equipment that's been turned off, you could still be in danger. That's because equipment can retain stored energy that can be harmful or fatal if released. For example, let's say that you have to change a pneumatic tool. There's a lot of stored energy in that hose and compressor. Or maybe you shut off the power on an HVAC unit before you make the repairs. That unit is still storing potentially harmful amounts of electrical current. But with the right preparation and equipment, you can control energy-related hazards and better protect yourself and your coworkers. When do you have to be concerned about an energy hazard? You need to be concerned under these two circumstances. Anytime objects can move or fall unexpectedly, or anytime extreme heat, electrical current, or gases or liquids under pressure can be released from tools, materials, or equipment. You're around these situations every day, so it can be easy to take these hazards for granted, especially because they're not easy to see. Stored energy hazards are different with every situation, but there are at least 5 main hazard categories you should watch out for on every job site. Mechanical, hydraulic, electrical, thermal, and pneumatic. Sometimes controlling energy hazards is as easy as identifying them and using safe work practices. Other times, they'll require more extensive control procedures and sometimes specialized equipment. Let's take a look at some examples from each of the 5 main hazard categories and see how each can be controlled. Mechanical stored energy hazards usually involve equipment that can move unexpectedly. Gravity often plays a role in creating these hazards. Here's a stack of banded pipe that needs to be accessed. There are 2 types of stored energy hazards here. The first stored energy hazard in this situation is the extreme tension in the bands on the pipes. These things are sharp and can be extremely hazardous when they fly loose after being cut. The second hazard is that the pipes can fall or roll as soon as they're released. That's why it's important to place the stack in a pipe rack or use blocking devices before cutting the band. And be sure to stand clear when making the cuts. Hydraulic stored energy hazards involve hydraulic equipment, like forklifts and jacks. These hazards are controlled much like mechanical hazards, by being aware, thinking through the situation, and using safe work practices. Although this equipment is built to handle heavy loads, there's always the possibility that the hydraulic system could fail. That's why it's important to stay out from under a load at all times, whether it's moving or not. Also, it's never a good idea to leave hydraulic equipment in the raised position when you don't have to. But when you do, be sure to barricade the area so others stay out from under it. Nobody gets hurt if nobody's under the load. Sometimes extra precautions are needed to control energy hazards, especially when servicing or repairing equipment. It's not good enough to simply shut down equipment, because what stops someone else from turning it back on? If that happened, the energy could be released, and that's when people get injured. Use a quick and easy procedure called lockout tagout to prevent the accidental restarting or manipulation of equipment on the job site. Lockout devices are placed on or over a part of the equipment so it can't be re-energized. Locks are used to secure the lockout device in place, making it impossible for equipment to be accidentally energized. Some equipment can accept a lock without an additional device. Locks should be strong and weatherproof. There should be a variety of lockout devices and locks available on the job site. Tags can be used as visual warnings when a device can't be locked out. A tag needs to identify you by indicating your name and contact information. That way people will know who put it there and how to contact you if necessary. It's rare in our industry to find a situation where a hazard can't be locked out. Tags should only be used as a last resort. Let's take a look at how to use Lockout Tagout to control some common energy-related hazards. Electrical energy hazards are the most threatening when you're doing service or maintenance on tools or equipment you plug in or turn on. For example, this HVAC unit has 480 volts pushing through it. Even when the power's off, there's still stored electrical current in the capacitor, so you'll have to protect yourself accordingly. However, after you've finished troubleshooting, you should turn off the power and lock it out. Then attempt to restart the unit to verify that it's been de-energized. When you're sure it's safe, you can start making the repairs. The lockout device should be placed on the circuit or panel box to make sure that it stays in the off position. In some cases, the lockout device is a small plastic clip that fits over the circuit breaker. When the lockout device is secured, there's no way for the circuit to be accidentally re-energized while work is in progress. Simply remove the lockout device when service is done, then re-energize the unit. It's also important to lock out electrical tools whenever you're changing attachments or troubleshooting. Turn the tool off and unplug it from the outlet, then use a lockout device on the plug. This will keep others from plugging it in before you're ready. Lockout Tagout should also be used to control stored thermal energy hazards, like working on a steam line. If you have to break into a line, shut off the valve and make sure it stays off while you're working by using a valve lockout device like this one. It fits over the entire valve, and when a lock is attached, the valve can't be turned. Carefully release the stored energy in the line, and you're ready to start work. Pneumatic tools can be hazardous because of the pressure stored in the compressor and the hose. When you go to change a pneumatic tool, first turn off the compressor, then lead the line. That way, the stored energy has been released and it won't get turned on while you're working. You've seen several examples of how to recognize and control energy hazards that you might come across on a typical job site, including mechanical, hydraulic, electrical, thermal, and pneumatic. You've also seen how to use Lockout Tagout to help control these hazards. Look for these and similar hazards on every job site. Remember, when it comes to controlling energy hazards, you can never be too careful. It doesn't take much extra effort, and it can prevent injuries and save lives. If you stay aware, recognize the hazards, and use safe work practices, you'll be able to stay in control.